Good morning everyone, or afternoon, or night, depending on whenever you're watching this video. So today we'll be going through circular functions, more specifically inverse circular functions. So that will mean your sine inverse graphs, your cos inverse, as well as your tan inverses. So sketching these graphs can be a little bit daunting at the start, but don't worry, that's why I'm here. I'll show you the number one trick to help you solve or sketch these graphs easily. Okay, so let's go into the basics first. What does a sine inverse graph look like? Well, it starts from -1, ends at 1 for domain, and our range is -π/2 to π/2. So a basic sine inverse graph would hence look like this graph. So that's what it looks like. Starts from -1, ends at 1, -π/2 to π/2. That means our domain is just -1 to 1, range -π/2 to π/2. So that's what our sine inverse graph looks like. If you take the inverse of the sine graph, that's what you should get. Okay, so with cos graph, it's slightly different. It still starts at -1 and ends at 1, but the range starts at pi and ends at 0 instead. And our shape looks very similar to a negative sine inverse. So that's how you would sketch your cos inverse graph. The domain, just like your sine inverse, is -1 to 1. The range, if we just have a look at this graph, well, it starts lowest is 0, highest is pi, so that's what our range is. And for tan inverse, our graph looks like this. Whoops, let me just have a better sketch. Crosses the origin, and we have asymptotes. So just like how our tan graph have asymptotes, vertical asymptotes, our tan inverse graph has horizontal asymptotes. Well, because it's the inverse of your tan graph. Domain is just infinity. This graph will just keep going on forever. And range, well, it starts from -π/2. So that's, whoop, just be careful. So range starts at -π/2, excluding that because that's what our asymptote is, and ends at pi/2. So those are your basics for sine inverse, cos inverse, and tan inverse. We have to be very familiar with these domains and ranges. Right. Make sure you memorize these, but they should also be in your formula sheet. But still, make sure you memorize them. It can help save a lot of time. Okay, now we'll move on to sketching harder graphs because these are pretty simple. We can all do that. Y equals to sine inverse 3x minus 1 plus pi. How do you sketch this? So step number one, there's a lot of transformation. We will look into the transformation that's going to affect our x, so that means our domain. We'll also look at transformation that will affect our y values, so that is our range. So step number one is looking at the domain changes. Initially, our domain is -1 to 1. Whenever you're sketching these inverse circular functions, we want to find our new implied domain and our new implied range, and those will help you sketch the graph. Very easy. Okay, so to do this, we put -1 smaller than 3x minus 1. So whatever's inside this bracket right here, just chuck it here. If it's x, chuck x over here. If it's 3x minus 1, we chuck that over here, in between the -1s and 1. Okay, afterwards you just solve for x normally. Just solve your inequation. So we bring 1 over here, so that's 0. Still got 3x, and we bring 1 over there, that's 2. Then we divide both sides by 3. 0 divided by 3 is still 0. And 2 divided by 3 is 2 on 3. So there we go. That is our new domain. That's how you would have to find your new domain. -1, 3x minus 1, and then 1. Whatever's inside the bracket, chuck it over here. Step number 2, you find your new range. So to find range, we use a slightly different method. Our original range for a sine inverse x graph is -π/2 to pi/2. Now let's look at our transformation. To look at transformation that will change your range, that will mean this number in front of sine and any number pretty much any values, any numbers that is outside the trig function. So that means this number right here, or that coefficient right there, and the number outside. Okay, so we don't have any number over here, so that we don't have any dilations. That's what's happening. We only have a transformation of pi units upward. So when we're moving our graph by pi unit upward, what we do is we take the negative pi on 2, we add that with the pi, so the transformation. And at the end of the day, we just have pi on 2 to 3 pi on 2. That is our new range. So our old range used to be negative pi on 2 to pi on 2. Now it is pi on 2 to 3 pi on 2. All we did was just add the transformations onto our old range. Okay, now moving on to step number 3, that is just sketching our graphs. Very simple. Okay, now let's look. Where does our graph start for domain? 0 and ends at 2 over 3. Where does our range start? Negative pi on 2, I mean, to 3 pi on 2. Why do I want to say negatives? Don't know why. Must be feeling negatives today. Anyway, what does our sine inverse graph look like first? So it's a positive sine inverse. We don't have a negatives in front of x. We don't have a negative in front of the trig function. So we just have a normal sine inverse, which looks like this. Therefore, we should start over here. 0 pi on 2, domain and our range. That's where it starts from. And we just sketch our graph. Should end up over there. Those are your endpoints. So 2 on 3 to 3 pi on 2. And this point will be 0 to pi on 2. And that's how you would sketch sine inverses graphs, or even cos inverse and tan inverse. Very simple. Step number 1, get your new domain. Step number 2, get your new range. Step number 3, make sure you get the shape right. And afterwards, just sketch your graph. Okay, now let's do a cos inverse. So this one will have, I'll add in some negatives, so with some reflection in there. Step number 1, cos inverse, sine inverse, tan inverse, you just follow the same steps. So we have to find our new domain. Always put the negative 1 in there. Have your 1 minus x, whatever's inside the bracket, chuck it in right over here, and we just have smaller than 1. Afterwards, bring the 1 over here. We have negative 2. Still got the negative x, and if you bring 1 to that side, we have 0, because 1 minus 1 is 0. Then we divide both sides by negative. Negative 2 divided by negative 1 is 2. And when you're dividing a number by negatives in an inequality, we flip the sign. So that means 2 smaller than x, smaller than 0. 0 divided by negative number is just 0. Right, so that's our new domain. It's between 0 and 2. And our old range used to be 0 to pi, and we need to transform that. How do we transform that? Basically, any values outside of the trig. So in this case, the 1 in front of here, the dilation, and also the negative pi on 2. And over here, no dilation, that's fine. We only just apply the transformation. So just add that minus that pi on 2 to both sides. 0 minus pi on 2 and pi minus pi on 2. We should get negative pi on 2 to pi on 2. Right, so that is our new range, and then our third part is just sketching the graph. So just get your graph over here. I'll try to my best to draw a straight graph. Alright, so this is we have a positive in front of the trig, but we have a negative in front of the x, which makes our cos inverse. So it used to be this shape, but since we have a negative in front of x, there's a reflection, and it should look like this instead. So this is a reflection upon the y-axis, and our graph should look as such. Okay, so just chuck in your new domain, 0 to 2, right here. Chuck in your new range, negative pi on 2 to pi on 2. And afterwards, just sketch your graph. Our cos inverse now looks like our sine inverse, the original sine inverse. So the only logical way to sketch this graph is it starts from this point, ends at that point. We can't start from here, ends over here, or else that wouldn't look like this shape at all. So we just start there, 0 to negative pi on 2, 0 negative pi on 2, to 2 pi on 2. And that's how you would sketch your cos inverse graph. Very similar to your sine inverse. Right, and lastly, we'll be sketching the tan inverse. So once again, just follow your steps. Tan inverse domain is always R, so it doesn't matter what kind of transformation you have, the domain will always be R, so that's negative infinity to infinity. The only part that you have to work out would be the range. So in this case, our original range for tan inverse is negative pi on 2 to pi on 2. and we will look at the transformations that will change our range. In this example, we have -2, we also have -pi. So which one goes first? So do we multiply this by 2, or do we multiply by -1 first, or do we minus pi first? So we look at Dr. T, which means dilation first, then reflection, then translation. So in this case, we apply the dilation, which is the coefficient of 2, multiply both numbers by 2, we should get -pi and pi. Afterwards, we multiply the reflection. If you multiply -pi by a negative number, we should get pi. And if you multiply pi by a negative number, we should get -pi. So we just swap them around. If you multiply negatives, you should be swapping these values around. And then afterwards, at the end, we apply the translation. So that's just minus pi. Minus pi is -2pi. Pi minus pi is 0. Number 3, we determine the shape of our tan inverse graph. A typical tan inverse graph, a positive one, would look as such. However, we have a negative in front of that tan inverse. The x is a positive though. So we just reflect it upon the x-axis. And that should look like this. So even if you reflect it upon the y-axis, it's still going to look the same. Doesn't matter how you reflect it, it will always look like this. And then let's proceed to sketching our tan inverse graph. So domain infinity, so don't have to label any kind of x values just yet. Our range is -2pi to 0. -2pi to 0. Okay, so make sure you label your asymptotes. That's -2pi. And then the other asymptote is at 0. Okay, so sketching this graph, well, let's see. We have our tan inverse. If you want to be fully accurate, you find your y-intercept as well your x-intercept, although in this case we don't have an x-intercept because our asymptote is at 0. You shouldn't touch any of the x-axis. But we can find y-intercept to be very accurate. So if you let x equals to 0, we have -2 tan inverse of 1 minus pi. Tan inverse of 1 is pi on 4. So -2 times pi on 4 minus pi. That should give us -pi on 2. Minus pi, we get -3 pi on 2. So that is where our y-intercept is. In this example, it's over here. So let's start sketching our tan inverse. Well, we know our shape looks like this. So perhaps the only possible way is... Whoop, let me just get a better sketch of this. And that's how you would have that's the shape you would have for your tan inverse. Beautiful. Okay, so today we finished sketching our circular functions, sine inverse, cos inverse, tan inverse. If you have any other questions, leave a comment below and maybe I'll get into it. But thank you for watching and I'll see you next week.